Hola, muy buenas tardes, muy buenos días a todos los que nos siguen en nuestra serie de webinars gratuitos de la Federación Mexicana de la Industria Aeroespacial. Muchas gracias a todos por acompañarnos. Nuestro webinar del día de hoy es Inspección Virtual Remota en turbina de aeronaves por John Murphy de Intertest Inc Technology. Les vamos a solicitar también que en el chat nos pongan su nombre y la organización que representan, por favor, sin hacer comerciales, pero solamente su nombre, la organización que representan y de dónde se conecta cada uno de ustedes. Bueno, y también para avisarles del próximo webinar de esta serie de webinars gratuitos, que se refiere a ¿quieres estar en el mercado aeroespacial internacional? Certificación SAE AS 9100 y AS 9110 del sector es el camino a cargo de TUBNORD por parte del ingeniero Ernesto Bonó, que es auditor experto de TUBNORD Argentina. Si se quieren registrar, bueno, pues ahí tienen el QR para que lo puedan hacer de una buena vez y puedan tomar la oportunidad de tomar este webinar. Bueno, también les avisamos a través de este medio que vamos a tomar una pequeña pausa, o sea, el próximo 8 de junio es cuando reiniciamos nuestros webinars con que planteamos, precisamente porque tenemos nuestra junta anual y todo el staff de FEMIA va a estar ocupado en eso. Entonces vamos a tomarnos una pequeña pausa, pero reiniciaremos y la intención es seguir con esta serie de webinars semanales a partir del 8 de junio, retomando los webinars. Bueno, platicar un poquito acerca de FEMIA. Es una asociación privada, sin fines de lucro, fundada hace aproximadamente 15 años, con poco más de 110 miembros en 14 estados de la República. Se estima que más del 80% de las exportaciones aeroespaciales de México son responsabilidad de nuestros miembros, de los miembros de FEMIA. Tenemos un enfoque nacional, ¿verdad? Y colaboramos con otros organismos afines, tanto a nivel nacional como a nivel internacional. También, bueno, ahí tienen un mapa, ¿verdad? Con los logotipos de las empresas que son nuestros miembros y bueno, pues esos son los que hacen posible el esfuerzo de FEMIA y en buena parte son los que hacen posible también el ecosistema del sector aeroespacial en México. Muchísimas gracias a todos ellos. También tomar la oportunidad de presentarles al staff, bueno, empezando por nuestro presidente del Consejo Directivo, que es el licenciado René Espinosa. Tenemos en la dirección de operación a Pamela Arellano, en la dirección de promoción a Mónica Vega y en la gerencia de proveeduría a Enrique Maldonado. Está Mariana González como gerente de gestión y membresía y Marta Ortuño en la asistencia de dirección y administración de proyectos. Su servidor Luis Liscano, presidente ejecutivo del organismo. Todos estamos para servirles y de hecho casi todos estamos presentes aquí. Muchísimas gracias y gracias a todo el staff por hacer posible todo el esfuerzo, no solamente de los webinars, sino de toda la actividad de FEMIA. La que sigue, por favor. Bueno, también avisarles, bueno, dos avisos. La primera es que este webinar será hecho en inglés. Nuestro expositor va a hacer su presentación en inglés. Y para hacer la presentación más fluida, les pedimos que a través del chat también, si existe algún comentario o duda, no lo externen a través del chat. Al final de la presentación tendremos una sesión de preguntas y respuestas la cual será moderada por un servidor. Y pues muchísimas gracias también por atender a esto. Bueno, y ahora presentarles a nuestro expositor del día de hoy, que es John Murphy. John has been involved in non-destructive testing, NDT, the aerospace industry for over 30 years, with an emphasis on imaging and remote visual inspection. Most of the last 30 years has been spent adapting and applying traditional LP disciplines to work effectively with the optical equipment and instruments. During his time as a provider of services and equipment for the aerospace industry, he has worked with clients all over the world. For the past 5 years, he has spent most of his time in Canada, USA, and Mexico, and has been very active with many of the major engine manufacturers and suppliers of magnesium and aluminum casting, always at the forefront of the new development of equipment that uses UV light inspection techniques to improve visual inspection. Experience is definitely critical in aerospace components. So please welcome John Murphy from IRS Technology from Intertest. John, welcome. This is thank you for collaborating with us, and we're very excited to see you here. So we now give you the microphone and camera for you.
Oh, very good. Thank you for the introduction. I'm really pleased to be here with everyone today, and the list of member companies in the Aeroespacial Federation in Mexico, it's impressive. I have to say, I wasn't aware that there were that many members, and impressive. And many of the companies, most of the companies, certainly familiar with in the North American market and beyond. And many of the companies I've certainly worked with over the years. And I'm just going to try to share the screen here now and bring up PowerPoint presentation, and at the same time try to make a little further additional introduction to Intertest. I work for Intertest. At the moment, I'm at one of my homes in Nova Scotia in Canada. I spend 50% of my time here in Canada, and I also have a location in Texas. With Intertest, our head office is located in Columbia, New Jersey, and that's a very beautiful area, rural area of New Jersey. And this is a shot of our manufacturing facility. We have over 40 engineering and manufacturing staff at this location. For my part, I generally travel throughout the world. Uh, our interest in the opportunity to make a presentation today was to um, uh, introduce perhaps some equipment that many of you are not familiar with. Intertest is one of the only manufacturers of uh, video equipment dedicated to ultraviolet light inspection or penetrant inspection with ultraviolet light for critical components in the aerospace. When I say critical components, my experience over many years has been with manufacturers, OEMs, and MROs who work regularly on landing gear and engine components, shafts and couplers and so on. And what we've found over the years, the video-based penetrant inspection. For all of you who are familiar in the industry, non-destructive testing industry, fluorescent penetrant inspection commonly used in a visual inspection activity to enhance the view versus white light. And in many cases that you're all used to with the handheld lamps, UV lamps for fluorescing the dyes. At Intertest, we've taken it one step further. And instead of the operator just relying on their own visual inspection with their eyes, we're using video and video components, most especially to access difficult to reach areas of drums, couplings, landing gear, and other complex parts. So it's at its roots, it's exactly the same as the traditional method with penetrant and a UV light using your eyes, but I think we've taken it a step further. And for any of you who are not totally familiar with the penetrant process, the penetrant, when applied to the surface of a component, we'll find all the little defects and so on, and the penetrant is stuck in those defects. And then when exposed to UV light at 365 nanometers, designed to kind of have a greenish fluorescing color. So in many cases, defects that you wouldn't normally see with white light become in full view with the UV and the penetrant inspection. It's a very well-known, simple process. As I say, we've just taken it to the next step of using video components to do the viewing instead of just the human eye. Now, some of the things that we can do that improve the whole process by using video is that we can enhance zoom and really get clearer images than we would with human eye. And for example, on cylindrical components, now that may be the internals of shafts or couplers. Over the years, I see people even in the most modern shops, MRO shops and so on, where they still rely on a mirror on a stick to view the internals. Well, as I say, we can do better than that with the video devices that are very compact and go view the internals of the components. Now, the other nice part that uh, is available by using videos that we can make a continuous log. So if we're looking at a specific part or component, we can maintain a video or an image archive of the whole life cycle of that component. And now there's a number of different ways to use the video equipment. There's both a manually inserted and then automated. Now we get into the motorized and programmable scans, and they become particularly interesting because they're completely repeatable, whereby we have a fixture that holds a part, and the camera will scan internally, externally, as the case may be, and we can repeat that same inspection on thousands and thousands of parts. Um, as I mentioned a few moments ago, that internal surfaces definitely pose challenges to any examiners, and the traditional mirror on a stick, yes, we can definitely do a lot better with the video components. And we get also uh, into these components that I started to describe a little earlier. Some of these components are probably look quite familiar to many of you, but shafts and then internals of housings. This is a cross section, but with internal webs, and in many cases, these have to be thoroughly inspected in all these webs. So we have, with the automated motorized systems, we can set up a part in a fixture and let just push the button and let the equipment scan the part. And once the information is archived, the examiners can evaluate any indications and recall or accept the part. And in most cases, cameras are designed for white light, and UV tends to be hard to view, but we use filters, and it tends to really optimize the imaging and really enhance the view for the operator. Now, again, it's a function of high quality equipment and control of the process, both moving the part and or the camera to make a repeatable inspection. Now, in terms of the UV, in the same manner with white light inspection, and, optical equipment, resolution of optical equipment is measured worldwide. What we call the gold standard is the United States Air Force 1951 resolution chart. And it's just a chart. It's got lines, horizontal and vertical lines in 9 different groups with different elements in each group. And with this, whether we're using white light or UV, we can basically quantify the quality of the video or the instrument that we're using. And very, very simple to use. And as I say, worldwide, it's a standard. So this image here is of with a UV rendering to show the resolution. Now, just to give you a comparison, we have 2 images here, the same part with the same indications on it. The one on the right is shown with white light, and the one on the left is shown with UV. And certainly, in many, many situations, the UV enhances the imaging for locating any indications or defects. Now, as I mentioned earlier, we have a number of different systems, as simple as handheld probes and cameras on manually inserted poles, but we also have dedicated systems that are cart-based and automated or semi-automated. And in our company, we have different trade names, but essentially vibes, and then we make a vibe cart for landing gear and also for shafts. And we have a web viewer for scanning those internal drums with the webs that I showed you the cross section of before, and for the internals of different couplers as well. I'm just trying to, there we go, to the next one here. So in its basic form, and many of you may have seen similar equipment, although I believe currently Intertest is one of the only manufacturers in the world of these types of systems. This system that's shown here is a cart-based system where we have the camera control programmer system, viewing monitor, recording and lighting systems, all on a cart. This particular one is designed for landing gear inspection. Now, we can make these in various configurations, and it's available up to some of the longest landing gear that I've seen on the the 380s and so on. They're 20 feet in length. We can accommodate just about any situation. And so just go back to the cart. In the landing gear situation, this pole, that system here, is on two different axes, whereby we can raise it or lower it, and it would be inserted through the internal section of the landing gear assembly. And when it's inserted, it can be orbitally rotated. The insertion pole can be orbitally rotated, so it can scan internal circumferences and various diameters. We can accommodate and various lengths, direction of view, and just any configuration that you can throw at us, we can handle. So, and now similar situation, this would be for a drum or a cylindrical part. And in this case, instead of inserting it through a landing gear, this is in a drum with webs inside the drum, and the camera will scan, and the operator can view and store the images. Generally speaking, the part that's shown here in this depiction, we would have a proper jig made up to suit that part, and the actual inspection process is programmed so it's repeatable. So at the push of a button, the operator can repeat 10 of those parts in exactly the same manner and create a log of the inspections. The cameras, for many of these inspections, we build these right in our New Jersey facility. They're high resolution. We're into the millions of pixels now in terms of image quality. Definitely in your HD high definition range, with both UV and white light on the tips. In the side view configuration, exactly the same idea. Again, all built in America. The cameras also have a device which to quantify the size of a defect. We have a series of little tabs that go in front of the image, whereby the operator, the technician, can apply the tab in front of the image and could say if it's a 1/8 diameter, 0.125 diameter indication or smaller. And um, so that it takes the guesswork out of it. It's not a true measurement function, but it certainly will give the operator an indication of what size defect he or she could be dealing with. And now, when we get into some of the more complex parts, again, same idea, insertion on a couple of different axes, but the camera position is arranged a little bit differently. And as we go along here, I'll be able to show you with the web viewer. We would go into a bore, and basically the camera will turn to a 90-degree side view type position, and we can use white light and UV on these systems as well, switch back and forth. So you can see here actually a pretty good depiction. The camera is rolled out through articulated uh, sheath that will deploy it right down in between the webs. And very, very simple, again, automated. And this, when placed inside the part, this at the push of a button, this system will just go through its cycle and view between every one of these webs. I have a little better idea of what we'll be doing with the cylindrical components, and I think it gives you an idea if you just think about how difficult these parts would be to inspect in a more traditional manner with a mirror or just by eye. And so again, it's repeatable. We can store all the images, and then create an archive for the whole life cycle of the component. There's various different configurations, so really we can see at any angle, 0 degrees, 60 degrees, 90 degrees, whatever suits the situation. And very simple cart format, both in manual and fully motorized carts. And I'm not sure what is in use in many operations in Mexico, but these systems are very, very common at the MRO shops throughout North America and Europe. Many of the major manufacturers in their MRO operations, they use these every day. And a little more detail on the camera boom and so on. It's just a very simple device, and controls. There's both wired and wireless remote controls. And we can configure these also to do cylindrical parts in a vertical position. So really, whatever you can throw at us, we've either done it or we can do it. And as I said before, the traditional UV fluorescing inspection is well known for many, many years. Most of the last century, people were using it as an inspection technique, but on the motorized cart systems, we've been manufacturing these systems for only about 25 to 30 years now. So it is just really catching on everywhere, but various other fixtures and so on. Now we, in addition to the carts and so on, we still use and recommend a lot of UV instruments that would be more of a manual processes. Um, in the video or UV borescopes and pole camera systems. And here's a good example of manual system for manual insertion on simpler parts. This can just be deployed by the operator and manually rotated and so on, capture the images, store them on the DVR that's built in. And pole cameras, again, we make them in many different lengths. I think I've seen them over 24 feet in length for various applications. Again, all that is in our New Jersey location and different tip adapters to suit just about any situation. And the two systems that I was showing you, both the pole camera and then the system for the web viewer, they can be totally combined. So we have many customers that like to have a very versatile system. Again, whatever the customer's needs are, we certainly build them. And they can be quite complex, then right down to some of the simplest instruments, as I'm showing you right here, for manual handheld insertion. And this particular unit here would be generally used in addition to the more traditional handheld UV type inspection, and where an operator can just simply hold the handy cam and view the images of a surface that he can reach with his hand manually. You could control the focal and zoom and so on. Now, this is not really connected to the aerospace industry, except just go on to show other applications that the same technology is used for, and it could be for guns and cannons and so on. And we do a lot of the smaller video instruments also for many different applications, especially these days. I've been quite busy the past few years with a lot of the OEMs, but also the supply chains to the OEMs with magnesium and aluminum castings, which were traditionally the internal passages were always done with white light. And now I've seen a big move to use video scopes, small diameter scopes with the UV light in the passages. And they're looking for linear cracks due to the casting process with magnesium. If there's, in certain cases, the O2 film that forms in the casting process can cause, indications, and almost impossible to see with white light. And we go to the UV light on those passages, and it just enhances everything. So the some basic things, as I was saying before, we certainly are on the cameras. We're well up into the HD range, 2 million to 4 million pixel imaging on on all this type of equipment these days. So in many cases, it's even better than Hollywood. And so our objectives in all this equipment is really to take a position especially in the aerospace industry, that that we can uh, match the requirements of the for the inspection required in a video automated or semi-automated process, and that we can, as the video technology gets better, that we can just continue to perform higher quality inspections. And so it's a sort of a process that never will end. I think in 500 years, I'm hoping that we'll still be trying to make it even better. And it's, I think, been very interesting to see some of the improvements by the implementation of this type of the technology, the improvements in a lot of the equipment that's manufactured, the OEM specs have become more stringent. It's in even 10 or 15 years ago, when we didn't have the technology to see certain defects, they didn't matter. Nowadays, we can see it, we can't ignore it, the defects and so on. Now, if anybody has any questions, I'm certainly delighted to answer any questions about the UV process, or any of the equipment applications. And beyond this webinar, certainly our representative, authorized representative in Mexico, IRS Inspection in Mexico, we work with them on a regular basis on many applications, and so they'd certainly be available to assist with anything. And but I'm certainly open to any questions if anybody has anything at this time.
Well, thank you very much, John. It was very interesting to see how you can lean on this kind of inspections and UV, and how this has developed over the years. It is certainly very interesting. Estamos ahora invitando a nuestra audiencia. We're inviting right now our audience to start posting their questions for John, so that we can actually ask them and see how things have evolved. I have one question, John. You mentioned that this UV way of inspecting has many years now. Okay. What is that you foresee is going to be the future in this kind of inspection? What is that we can expect over the next 5, 10, or 15 years ahead?
Yeah, sure. One of the things that I've experienced already is that let's go right back to what we call the visual inspection, and or remote visual inspection with the use of various instruments. Is that maybe some years ago, a lot of people would think that visual inspection may become somewhat irrelevant with the advent of radiography and other types of scans that could be used. But in fact, I think with the improvements in visual inspection, and again enhanced with UV light and so on, I think it makes the visual inspection even better and more important in terms of being able to, on the basis of a visual inspection, accept or recall a component, or even at a minimum, the visual inspection can be used as a qualifying step, whereby the operator may determine that there's further testing with radiography, as the case may be, beyond the visual inspection. So it's just continued to improve, and I think as video technology improves, the visual inspection will be more and more relevant moving into the future.
Thank you, John. I have a question here from Javier Martinez. He's saying that if this equipment applies for PT process, I don't know what that means, or if only has light for in order to identify discontinuities.
So the question was, if it only applies to the penetrant process?
If it could be used for PT process. I don't know what do you mean by PT, Javier? I don't know if you can further explain what kind of process is that. Well, in the meantime, Cesar Gomez is asking if the equipment has a way to measure the separation between the target and the camera.
Yeah, absolutely. We can do that in a couple of different manners. By instead of one camera, we would actually use two cameras, whereby what we call stereoscopic viewing. So the two cameras are a known distance apart from each other, and the images are intersect. They're positioned to intersect at a known distance. So by very simple, what we call triangulation, anything in that view, we can determine the distance away from it. So if we're looking at a surface, we would be able to, I mean, I don't calculate it, the actual, processor makes the calculation. We can tell you if we're 2 millimeters, 5 millimeters, or 20 millimeters distance from the substrate.
Excellent. Thank you, John. Okay, concerning the previous question, PT is penetrant testing.
Yes.
Okay, if this equipment applies for a penetrant testing process, or only has a light to identify discontinuities?
Yeah, no. So with the UV light, it would be the same liquid penetrant that would be used in other manual processes designed to work at 360 nanometers per centimeter squared in the wavelength, and so we would fluoresce that. Now that works well, we find, on certainly magnesium and aluminum components, but the entire system can also be very effective with magnetic particles
Yes.
on ferrous substrates. So if it's a magnetic substrate, then the mag particle works quite well. So it's quite versatile.
I guess Javier is asking that in order to have this remotely, you may need to have somebody to prep the substrate, right? you
Oh,
know,
yes,
with the penetrant liquid in order so that you can
yes,
apply the UV light.
yeah,
So you actually need somebody physically where the substrate is, so that he can apply the penetrant liquid in order for you to watch remotely the UV light, right?
yeah,
The
well,
UV fluorescence. Uh-huh.
yeah, absolutely. What we see in a lot of the facilities would be where they would submerge a part in a tank and then flush it and wash it to prep it for the actual inspection process. And so it um, now we do have situations certainly that differ from that. If we get into some of the um, applications where we're using small diameter video scopes in passages and castings, um, they would just simply be flooded with and flushed with a tube of like a squirt bottle of penetrant and then flushed out before the process. But on the larger parts, they're usually put in a bath first and then put on the automated system.
Excellent. Cesar Gomez is asking for, you know, an address to, you know, check the equipments or information to get the prices and things like that. I understand that IRS Technology is is representing you here in Mexico, right?
Yeah, I've been personally working with IRS Technology for many years now on different products in the industrial setting, and I think that we've always had a desire at Intertest to become more involved in the Mexican aerospace, and so I think IRS technology, they're certainly positioned very well to you know, work in that space with our support. It's as I say, we have our systems around the world, but on a day-to-day basis, it's always hard to be everywhere, and so we have a you know, selection of really good, you know, partnerships, and IRS is certainly one of them over the years. But in terms of information, um, I would recommend certainly contacting Andres Martinez at IRS, and certainly shown on the screen at the moment. But at our own intertest.com, there's a lot of content on UV applications, and I'm certainly readily available. I would say more than 50% of what I do on a day-to-day basis is involves UV, and you know, a lot of the major OEMs and repair shops as well. So we're certainly open for contact on any of those topics. And
Excellent, John. So, basically, si a alguien le interesa alguno de estos equipos o ver o especificaciones, obviamente pues hay que contactar a Andrés Martínez de IRS Technology. Aquí, ahí están los datos, están puestos en la pantalla, y para referencia adicional, pues en el site de Intertest, intertest.com. Bueno, we have another question, John.
yes.
Mariana Ortiz is asking that, you know, in your experience, you have been extensively in North America, United States, Canada, and Mexico within the aerospace industry. What kind of difference do you see between these three countries in the aerospace industry? You know, what, is there a big difference between the three of them? What do you see? How do you compare Mexico with the United States or Canada?
Yeah, you know, it's interesting. I think the the regulatory process, I think all three countries are probably pretty well aligned these days. I mean, they um, on the world scene, everybody's getting in line, so the industry can expect the same level of high quality inspection and manufacturing processes, really wherever you go. But I think especially in Mexico, Canada, and the USA, um, I really believe the quality of the people and the manufacturing is is very similar. I think it's really the I I don't have good comments about the participation. I think it's come a long way over the years, and in fact, uh, as our topic today of the UV discussion, and I keep going back to it. Even 5, 10 years ago, uh, we didn't have the technology to see what we can see today on parts and inspection. Uh, and now we see so much more, and the industry is responding well. They aren't ignoring anything. I think they're embracing all the newer technology, and it's really makes me. I certainly believe that the industry is going to continue to get better and better. Certainly on North America, Mexico side of things.
Excellent. Thank you, John. They're asking, Roberto Barrios Sousa is asking if you have some video just to see the equipment in action.
Yeah, absolutely. May be able to, well, actually, on our website, it might be easier on our website, or you know what, if anybody wants to make a request, they could send me an email at jmurphy@intertest.com.
If you want, we can post John's email address on the chat. Would you please, Enrique? Okay, so that they can you can actually make a specific request to John so that he can send you links to videos and things like that. So exactly.
Yeah, I have a lot of content.
Okay. I don't know if that's could you repeat the email, John?
Yes, it's jmurphy@intertest.com.
Exactly. Okay.
Yep, and I have a lot of content in the form of video, both with automated and manually manual processes that certainly could be helpful on different applications. And so, yeah, if anybody had any questions, I could send specific information out.
One last question, because time is running out, unfortunately.
No,
but one last question is, Arturo Torres is asking if it's viable to use UV light inspection with drones in order to inspect aircraft, for example, commercial aircraft in maintenance inspections. Will that be viable? Do you think that's viable?
Well, that's a great question. I think I don't know, but I think it's something. It may just be a process of evolution, and what we think is impossible today, I mean, wait till next year. You just never know. But on that topic, we've all had a few years, 2.5 years of COVID experience. I met a company, a drone company, over 2 years ago that were using UV light, but not to enhance imaging. The UV light actually would be dangerous UV light, but it was designed to use on a drone and fly around inside buildings. And the UV light spectrum they used for those applications was to kill the COVID virus. So it's not quite like our safe UV we use in inspection, but so yeah, anything's possible for sure.
Well, thank you very much, John. It was certainly a very, very interesting presentation. And, on behalf of FEMIA, we certainly are very, very grateful with you and IRS Technology to make this presentation possible. So thank you very much. And, we certainly acknowledge your participation, and we're very grateful for that.
Yeah, my pleasure, and look forward to maybe seeing more of your members in the near future, for sure, on travel to Mexico.
I'm positive that that will be the case. And again, time is running out. We certainly would like to thank you for attending this webinar. Y queremos solicitarles que nos sigan, por favor, en nuestras redes sociales, tanto en Facebook, Twitter, en el canal de FEMIA en YouTube, donde se ponen precisamente estas colaboraciones, estos webinars, en LinkedIn y, por supuesto, en nuestro correo de contacto. Y bueno, terminar extendiendo la invitación para el próximo miércoles 8 de junio. Como les dijimos, la semana que entra no estaremos fuera del aire con nuestros webinars, pero retomaremos la actividad del 8 de junio con el tema de certificación AS 9100 y AS 9110 a cargo de TUBNORD a las 11 de la mañana, tiempo del Centro de México. Otra vez, ahí está el QR para los que quieran hacer su registro desde ya. Y pues agradecerles a todos el favor de su atención. John, muchas gracias y nos vemos el próximo 8 de junio. Que tengan un excelente día y un excelente resto de semana. Muchas gracias y hasta luego.
Muchas gracias, Luis.